Okay, great.
All right, ready?
Yep.
All right, hello, everybody. Thank you for coming to the VEC. Welcome to our first session in 2023. This is the first of 3 sessions we're going to be doing on Design Assist. So I'm really excited to have the group here, but I'll let Sarah do the introductions today and tell you a bit about our presenters. Thank you.
Hi, everyone. For those who don't know me, I'm Sarah Kravitz. I'm a quality manager at Consigli, and I'm the past chair for the Boston Tech. So before we get started, a couple of housekeeping items. If you guys can save your questions to the end, we'll have a Q&A session. And also for those of you online, in the chat, there's a link where you can sign up for LU credits. And then there's also a clipboard that can be passed around where you can write down your email if you want to receive credits as well. But to get started on this presentation, I had the amazing privilege of working with these 2 gentlemen to put this together. So I would like to introduce you to Chris Brown. He is a senior superintendent up in the main,
Project
project executive, sorry.
Got promoted.
Yeah. Project executive up in the main office. He's been with Consigli for 17 years now, where he's worked on numerous higher education projects and was intimately involved with the Colby project all the way from design assist to closeout throughout construction. And then we also have Jerry Gutierrez, who has been working with 15 years at Sasaki. Is that correct?
Yeah.
So he's also been working on a plethora of higher educations, but specifically on athletic facilities. So without further ado, gentlemen, I turn the floor over to you to talk about a little bit your roles and take it from there.
Right.
Okay, yeah. Thank you guys for coming. As Sarah says, I'm Jerry Gutierrez. I'm a senior associate over at Sasaki. I'm also a member of Sasaki's technical resource group. My involvement in the Colby project was as project architect. I was involved starting at the beginning of design development and carried it through all the way to contract administration, working with Chris.
My name is Chris Brown, again, project executive with Consigli Construction. My role on the project was leading the construction effort, partway through pre-construction, all the way through construction into closeout, and more specifically, as it relates to today, in the design assist effort, both with our mechanical electrical companies, subcontractor partners, and also with the envelope work, which we're going to talk about today.
Yeah, so today what we want to do is sort of clarify and define what design assist really is, and sort of go through sort of the misnomers that we often come across. We also want to talk about the roles and responsibilities of the players involved in the design assist program. We want to get into the sort of the performance testing that happens after design assist. We want to get into like mock-up testing, and then finally we want to wrap up on sort of lessons learned. You know, what are the challenges and risks that we've come across looking back after the process.
So what we have here, just to set the record straight on the different types of delivery methods that often get used synonymously with each other, but are obviously quite different. Design build, this is the approach where the construction manager traditionally gets hired as the design builder, and then will subcontract to an architect, engineer, and then subcontractor trade companies to complete the work. So a pretty linear approach, one path, straight down. Delegated design, this is where there's a little bit more collaboration between the relationship between the owner, architect, contractor, 2 separate contracts, one with the architect under the client, one with the contractor. But the architect will delegate a specific component of the design to be led by the contractor, whether it's curtain wall may have aspects of it, structural steel connections, miscellaneous metals or stairs. There's a component that they will pass off and the contractor and delegated design contractor will take the lead.
So for delegated design, the architect's responsibility, since the contractor is responsible for the design, what we have to do is provide the performance requirements in the contract. I mean, those are the guidelines that a delegated designer has to adhere to in order to meet the intent of the contract. But the design and liability is to the contract.
And design assist. This is the approach I'm going to be talking about today, which is more of a collaboration between multiple parties to assist the architect or engineer in creating an overall design that they will own. This may lead into other portions that have a delegated design component, but ultimately the design itself will be collaborated together and owned by the architect.
Yeah, and so I have to admit, like the confusion between design assist and delegated design mostly happens with the design team. I think the construction team are very clear, you know,
We don't know the roles.
exactly. But the design team, they think that, you know, design assist is delegated design starting early. So, you know, I've run across where some people expect the design assist contractor to start into job drawings, start into engineering, and that's not the case. In design assist, the architect is still responsible for the details, for the contract documents. The design assist contractor is there to help us develop those details, but we are doing the drawings, we are writing the specs for that system. Ultimately, it will go into delegated design, where the design assist contractor would take over the design, but until then, the performance requirements is on the design team.
When is design assist most beneficial? It's not a one size fits all approach. It's not going to work in every scenario. There are plenty of delivery methods out there. Some may be better suited for others. But when it comes to design assist, we found in our experience, the more complex the system, the more applicable it might be for a design assist approach. So these are just a couple scenarios. I'm not going to go through them all. Again, complex custom assemblies, highly specialized where the design may not be quite straightforward, that everyone may have expertise in. You could value participation from outside companies, outside resources, and to get them involved early. But again, anything can be a design assist trade if it looks like it's going to be an environment where they could benefit from a lot of collaboration between different parties. Defining design assist roles and responsibilities. Again, this is a bit wordy, so I'm not going to run through all of them. I won't put everybody to sleep, but some of them that I want to touch on, some themes that you're probably going to hear throughout this presentation. Design responsibilities, liability, and ownership. It's very clear, or it's very important to establish those clear guidelines, roles and responsibilities very early on. Now, some people do it differently. We've found considerably it's best to set up a matrix, have all the players, have all the expectations and responsibilities, and assign those early on so people know what is expected of them going into that effort and the level of participation. That gets into the next highlighted item, that level of participation. Is there an estimating component to it that the subcontractor is going to have to be part of? Is there going to be modeling involved? Obviously, there'll be constructability review, but how many meetings? Who's going to be at the meeting? What's expected of them of the meeting? Is there going to be a whole deliverable? These are many questions that we tend to get from subcontractors and other participants when they're trying to put a competitive bid together for that process. And we try and lay out as much information as we possibly can to them to explain the process and what's going to be expected of them. And also at the end here, clearly identify where pre-construction ends, the design assist effort, and construction begins. Does have a tendency to blur the lines, especially if you have to start delivering or procuring materials as part of this effort. So again, with that matrix and assigning those responsibilities, make that effort clear. And when is it going to start? When is it going to finish? when is it going to go into construction? Because they're often two different contracts. And they could, I'm not saying they do, but they could always be two different companies as well. One could be doing a design assist, one could be doing the construction. Unlikely, but it's possible. And just some of the resources that people have when it comes to a design assist contract. Up until more recently, it's really just been a pre-construction tool using a standard AIA A133 contract and then defining what the design assist effort is going to be with all those slides that we previously talked about. More recently, that says C403 2001, but it's actually 2021. They have come out with a design assist supplement for the AIA. I haven't used it yet, but I've gone through it and it takes care of a lot of the legal, the boilerplate. And it just leads the team to defining what that effort and that participation is going to be. So it's a big help, a big time saver. You don't necessarily have to bring it to everybody starting from scratch with your corporate attorney. So it definitely helps. And then consensus docs 541 is another supplement. I have not used it, but other people have and say it is helpful at organizing the design assist effort contractually. So those are some of the tools. Those are some of the tools that are at your disposal when trying to set this up.
So on to our project, the Harold Alphon Athletic and Recreation Center over in Colby College. Colby College hired Hopkins Architect from London and Sasaki to design a state-of-the-art athletic facility. That facility contained a 50-meter pool and an aquatic center, performance gymnasium, performance ice hockey rink, 9 squash courts, a field house containing indoor track, lacrosse field, batting cage, throwing cage, and a sports medicine suite. The view you see here is.
Sorry. Just let me
the,
know when you want me to change.
Okay, yeah, this is what we're going to be talking about, the field house and the challenges that we face to deliver that. But the program that Colby had was really ambitious. They wanted to create a new gateway into the campus and create a campus center for athletics, for health and wellness and recreation. The program was huge. It was almost 350,000 square feet, all enclosed under one roof. And at the time of the construction, it was the state of Maine's largest construction project. Sustainability was a major driver in this project for Colby as well as for Sasaki. We were able to achieve LEED Platinum and CITES Gold, which is the site and land development sustainability goal. A lot of the LEED Platinum was based on the innovations that we've introduced on the design assist process we're talking about.
It was so large during construction. Colby was getting calls asking why we were building an airport hangar right down off their main road. They were not happy about it. So they explained exactly what it was. And then slowly comments died off, but it was definitely much larger than everyone was used to seeing in that area.
So right off the bat during design, Consiglia was focused on what are the upcoming project challenges. And as usual, it's cost and it's schedule. So we've always been kind of challenged to select the right envelope for that field house, and the design team has gone through, what is the facade? Is it brick masonry? Is it precast? And we've went through a lot of iterations. But at the same time, Consiglia identified the fact that the field house needed to be enclosed in that first winter. If they weren't able to achieve that, schedule is going to be lost, things are going to be set back. And so that almost kind of negated masonry or any kind of wet system going on there. Consigli came up with the idea, it's like, why not use insulated metal panel? Because it's a quick erection. You have a single contractor to coordinate it. He can literally build the entire facade in one panel and stack it that way. Which is, I'm sure that's what Consigli would like to do, but the design team had other thoughts on it. But we were intrigued with the idea of an insulated metal panel. We liked the idea from that system. It's like, you know, typically it's all sort of set up and screwed into structure. But we were thinking, you know, if it's a panel system, why can't we treat it like a curtain wall? So can a panel be integrated in a compression system, not unlike a curtain wall? And that sort of conjured up some other ideas that aesthetically, you know, we could sort of set datums that sort of ties into the other portions of the building. We also had the idea that, you know, we can make the panels, you know, manageable enough that if a panel ever were to be damaged, that the owner could simply just remove the pressure plates and just swap out the panels. And we love the idea of no penetrations through the building envelope. And when we thought about it some more, we thought that can we take advantage of the inherent structural integrity of an insulated metal panel you know, normally you would have to support a panel like every 7 to 8 feet going up back into structure. And we're thinking instead of doing that, can we sort of establish a compression system where we can deadload the panel at periodic locations and just take the load back into through an extrusion into the building structure. And it allowed us to increase the spans from like 7 to 8 feet to more like 18 feet. So it was a pretty substantial increase in span, and still thinking no fasteners. So in our so this is even before design assist came on. We pulled together our design development package, which Chris used as sort of the bid documents for design assist contractor. And we identified the stack joint as sort of the critical component for the system. So at the time, we didn't know what that would be, but so we kind of indicated a sort of a compression system that the top panel deadloads to it and transfers to the structure. The bottom is laterally supported, and it also allows us to sort of integrate other systems. So we had you know, the opaque system of the insulated wall panel. We also had fiberglass translucent panel used as a clear story system, and we also wanted to integrate a curtain wall. And so at design development, we're not thinking that we can integrate all these components together. So we're keeping it separate. We have the stack joint, but this extrusion stops at the head and the translucent panel picks up, and everybody's responsible for their own components. Same with the curtain wall.
As you can imagine, just taking a look at that and trying to estimate it or figure out who's going to do what, how would we put this out on the market to bid this and know who's doing what without a lot of finger pointing? So everybody was very clear on what the intent was and the aesthetic and the performance they were going for, but trying to work out the fine tuning and the detailing of these assemblies was clearly going to be a challenge. So why did the project require design assist? Well, as we mentioned in some of the slides ago, this was heavily custom. The extrusion that Jerry and Sasaki were talking about is custom. An insulated metal wall panel system has very few components. It's meant to be supported every 6 or so feet. But if that was the desired aesthetic on the inside, it wouldn't be desirable. So understanding Sasaki's intent to try and eliminate that substructure and just do it at major 12-foot, I think, intervals, we're gonna have to do something completely custom. We have to integrate multiple manufacturers within someone else's system. So unlike the ability to say do a delegated design, we don't necessarily know how to do it, but the contractor and the manufacturers have expertise, they can figure it out. In this case, it was going to be circular. It would just keep coming back around. Well, I need this from you. Well, I need this from this other person. It'd be too much information to do linearly in a traditional delivery method, since so much needed to be resolved together. Obviously, there were high performance expectations. Constructability, obviously, as we pointed out, was a big concern, where to draw those lines of ownership. And equally important is the overall aesthetic that Colby, Sasaki, Hopkins were desiring for the field house. As I said, traditional bid build wasn't going to do it. It would have added at least 6 months on the project and would have been much more adversarial. That, and we needed real-time cost information. We couldn't roll the dice that we think it's going to be about this, but no one's done this. It's custom. We didn't want to roll the dice and say, yeah, it's going to be this much. We needed real-time cost information on what we were designing at the table within a couple of days afterwards, so we could make sure that we were still on budget and on track, or if we had to recorrect, go in another direction. Those were the challenges we were faced with, and these are the players that we had. Now, this organization is very similar to what we would have with a traditional CM at risk type contract. But you can imagine trying to do trying to design through this process in this form would be very cumbersome, and it would take a long time. Sasaki working with Arup, working with manufacturers, Kingspan, who's the insulated metal panel manufacturer, Major Industries, who was the translucent panel manufacturer, and Schuco on the curtain wall. They would have thoughts, ideas, and that would come back up and around to Consigli. Consigli would then feed that back down to Total Wall. Total Wall would feed that to Cherry Hill Glass, one of their glazing subcontractors and their own labor force. They would come back and say, well, that's not going to work. We have a bunch of RFIs. We have cost concerns. This isn't going to work. And then it goes back up and around. It just keeps going like that. An RFI could take at least a week to get, or we could be at the same table. Is that going to work? No, it's not. We need to think of something else. So those were the people involved. That was the contractual relationship. But the design assist approach, all those players were sitting at the same table at the same time. It was immensely efficient and productive. So what we were looking for is each party had similar goals and some unique goals, as you would expect, architect, contractor. So some of the big ones for Consigli was we needed to make sure that the details that were being generated were real. Are we going to be able to build from these? Are we going to be able to cost from these? And is it going to perform the way it's expected to? We need to have some degree of certainty of that, and again, not wing it. And we need to reduce the frequency of designing through the shop drawings. Immense amount of time, again, going back and forth, trying to get a concept to work. It's very time consuming, trying to do that in a traditional method.
And for me, part of the design team, what I loved about the relationship is that we're able to prove out the concept utilizing the actual manufacturers and installers working with us to execute that detail. And consequence of that is like, you know, I'm feeling better. I feel like there's less risk when we go out to the field. I have more confidence that the detail is actually going to be executed the way we were envisioning here. So a lot of benefits from the design end for that as well.
Procurement and supply was important for us, the contractor. We needed to make sure that we had the ability to pre-purchase some of the custom fabrications. Again, they're not coming off of a standard assembly line. We were going to have to schedule for some of these custom extrusions to be built and delivered. That was going to take more time. Again, waiting until the end of the procurement process to do that would have pushed everything way out. So this way we were able to overlap some of that time, and it blended right in with the rest of pre-construction and the tail end of design, beginning of construction. We didn't lose any time.
For the design team, the fact that we were able to follow up with some quality assurance testing, performance mock-ups, something that we normally wouldn't see during the design process or after we finish design and go through the delegated design. We've kind of lost the opportunity to have a performance mock-up. With design assist, we're able to sort of front load that design, get to a point where we're comfortable that in our minds we've proven out the design, and we're able to go to a performance mock-up to actual test design.
Beneficial to all parties was fewer changes. No one benefits from changes, absolutely no one. Subs don't want them, contractors don't want them. Client doesn't want to pay for them. Design team doesn't want to issue them and go through the obvious effort of having to produce them. By having everyone at the table, I can tell you, the subcontractor and the contractor are going to be in a pretty difficult spot if we were to have to go to Jerry or Colby and say, well, we need a change for something, because their answer is always going to be, you were right there at the table. What's the problem? So it really takes away a lot of that risk. I think we through the project had very few changes when it came to the envelope system.
So by this time, Consigli has signed up Total Wall Systems out of Connecticut, and they were the facade contractors who own both the insulated metal panels, the fiberglass translucent panel, and the curtain wall. So one contractor controlling all three envelope systems. And they recognize from the fact that it's the stack joint that's sort of the key to this design. And so in our meeting, Total Wall brings in Kingspan. They bring in Major Industries for the translucent panels. And we're all sitting at the table together to see how our respective systems can work together. And so Kingspan's engineer was at the table, laptop, CAD system in place, and generated this extrusion from the discussion. The performance requirements that extrusion had to adhere to. And from that is sort of like our basis, our key. And more interestingly, it's like, so this is not from the design team, but from Total Wall. It's like initially we're thinking 2 3/4 inch fiberglass insulated panels. Take the extrusions that they use and set that into this extrusion. Major Industry says we've got a 4-inch panel, sort of the same thickness as an insulated panel. Why don't we just kind of glaze into that system? So now it's like we've removed a redundant metal framing system. Now we've got like 2 different envelope systems going into one extrusion. we're still thinking no penetrations. And so, you know, this is design team idea of doing like an anti-walk clip that fastens between the joints. So so to avoid any kind of penetrations through the panel. In the end, Total Wall says that's a no-go. It's like theoretically you can do it, but we can't run the risk of a panel sort of walking on us, tipping on us. It becomes a safety factor. So a little compromise has to happen, which is sort of the nature of design assist. We reduced the penetrations a lot, but there are, you know, in the end, they had to sink a screw in just to hold the panel in place. So once we had that extrusion, the design team took it over and says, okay, what kind of iterations we can do to modify and use this extrusion. You know, we had a T shape. We developed an L shape to create corner conditions, jam conditions. And so we now have the parts and pieces that we can put together and integrate it into our details. And so, you know, from our design development, our kind of naive, you know, desire of a compression system, we have a fully developed construction document set that can go out into the street, can be actually priced because everybody understands, you know, what the responsibilities are. We're able to control sequencing to get all the necessary tie-ins into the system and to work out details that aren't necessarily critical to the success of the insulated metal panel, but it has an architectural significance. So, you know, we had this C channel that defines the cornice of the building and ties everything together. Working with the contractor, we were thinking it's like get a C channel, hammer a clip on it, put a tab on it, call it a day. Contractor says, no, let's custom extrude it so we can get the actual clip and the actual flange that we need that won't go on site. So. And the stack joint system that shows, you know, how that one extrusion can marry insulated metal panel, can marry the fiberglass translucent panels. But in the end, curtain wall was its own thing. So we were able to sort of make that separation and integrate it into it, but not expecting that the curtain wall system to be engaged with our extrusion. And so, yeah.
So then after we went through the majority of the design assist portion, we said, all right, we think this is going to work. Why don't let's run some of the custom extrusions and produce a performance mock-up. Everyone's happy. At this point, we've gone through not just with the compression fitting that we're highlighting here, but the base, the intermediate, the transitions, the head, around doors. There are probably about another dozen or so assemblies that we worked on together and worked through. But this extrusion, this custom extrusion, had a long lead time, and we had to get it there so we could go through the rest of the steps, test it, make sure it's going to work, get any bugs out of the system before we start putting it up on the building. So this is just some shots of the actual extrusion.
It's important to note too, it's like we're still halfway through the design assist process. But scheduling kind of required that that Colby made a commitment to go ahead and make that extrusion. So I have to tip my cap to them. You know, it's sort of a leap of faith that none of this has been tested, but we need to go get the extrusion fabricated. So this was like a year before you know, we needed it on site that they said go ahead. And those extrusions.
No pressure. So this is just some shots of the performance mock-up. So again, we tried to take as many of the custom assemblies, put them on this outside corner where we thought the most vulnerability was going to be, and test it. At this point, we've had numerous meetings, design sessions, reviewed the model, yelled back and forth. Ultimately, happy, very happy with the end result. And I might say a little cocky about where we were going into the performance mock-up. So this, I think, is our, nope, we'll go back. This is our
Sorry.
first test,
My bad.
our first test. There was hope that this was gonna go well. We thought we got everything detailed. And it failed miserably, painfully miserably. Now, I'm not saying it's raining on the other side of that, but clearly there were problems with the test chamber, just air migrating around, and some fine tuning that we needed to do with the mock-up in order to get everything just right. So we ended up having, I want to say, at least three tests, maybe more. And over the course of it, we used on the far left, that's a smoke pen. When the answer wasn't obvious, where is the water coming from? Where is the air coming from? We took a smoke pen, put negative air on one side, positive on the other, and then we just followed the smoke. And that was immensely helpful because I don't know if we would have found all the little holes without it. And over the course of doing it, then we had to figure out, all right, what's causing these failures, these leaks? Some of it was with the manufacturer. You can see the middle photo, the butyl, which is, think of it like silicone that never cures. So that's fun. Wasn't completely top to bottom on the panel. There were little gaps. And when those two panels come together, those gaps, we're going to get air pulled in, we're going to get water coming in. So Total Wall said, okay, we're not gonna 100% rely on factory butyl. We're going to install our own, both at the base and at the vertical lip, and then again on the seams. And then over on the far right, there's a gasket, a compression gasket that was used, and you can see where it starts to travel off and not have a good seam, even though that's compressing, is just a little gap where air can come in. That had to be fixed. Next one. So this is just them putting on trying out double layers of butyl, which is the standard product that you use with the insulated metal panel. You can see a panel being raised up, thinking, okay, we'll just put more goop in and that'll fix it. And ultimately, again, had less problems, but still problems that we had to figure out, and went through a couple other tests. And ultimately came away with modifications or some supplements to the extrusion. Ultimately minor, but the weeps, see here, that were drilled into the pressure plate of the compression fitting were too small and too far apart. There was too much water being introduced into the system, and it couldn't handle it, and that pressure was causing the water to push out the backside and up the vertical leg. That's not going to work. So bigger weeps closer together, and then also introducing a foam compression fitting on the horizontal and on the vertical prevented the butyl from sagging or oozing out, kept it where it needed to be. So it wouldn't over compress and then fail under extreme temperature conditions, which we also had to test. And then also using butyl and foam tape over the screw penetrations, because we were still getting some air even through that screw that was causing us to exceed the threshold. But after all these were addressed and corrected, it passed. It was extremely tight from air, water, and we could move on to the next phase.
It's interesting, we always hear that you want the contractor doing the work to be the one who's building the performance mock-up. And that example makes a lot of sense because there is so much lessons learned from that performance mock-up that the contractor needed to take with them when they came out to the site. So once we got the performance mock-up all pulled together, it was time for shop drawings. And I wanted to put the comparison between what we develop in construction documents versus what we have in shop drawings. And so from the outside, pretty much the facade was executed the way we wanted to see it. The only differences we see are the anchoring, and that's a result of engineering that happens during delegated design. But for the most part, the extrusions all pretty much maintain. The relationships all pretty much maintained, and they were able to deliver the facade that we were expecting. The sort of the same story in this case. The one thing I did want to add, because the whole concept was the panel dead loads onto the extrusion. When you have a floor on top of that, metal panels do not like live load deflection in there. And so when we did the ice rink, there's a floor right at that line. In the field house, this is a fixed connection. In the ice rink, that has to be a slotted connection to allow for the separation of the floor to the onboard system.
And these are just some field shots of some of the work being put in place. Again, these are the outriggers that go from the structure out. And we've got a little bit of a slip joint there until all of the load is put on the steel. Then they can be cranked down. And then on the middle photo, you can see that was a piece of T steel that we had to put up to support the major industries translucent panel overhead. And there was going to be curtain wall down below. It was one of the intermediate joints that we had to work out. So again, everything starts with the outriggers. The outriggers were manufactured, installed with the structural steel. But again, that tolerance of the steel, even some of that steel would sag in the middle. So we had to have a way to compensate for that because there could be really no give in the extrusion that could not sag. So that allows for some of the adjustability. And then on the far left, probably can't see it too well, but that's just a shot of all of the extrusions attached to the outriggers in place before panels go. This is just a quick look at the base condition. The base had so many parts, hard to show in just the 3 shots here, but on the far left, this is with all masonry installed, obviously all the concrete, flashing, the air vapor barrier, the continuous air vapor barrier, and the support angle that the extrusion would eventually bolt into at the base. The middle photo, this is of the base extrusion being installed ahead of the flashing, ahead of the panels going on. And then the far right, you can see the panel starting to go on. Again, this is that foam compressible filler that was added. There's also one on the vertical, just to keep that butyl from oozing down into the flat. But that's pretty much how they went together. They went up very fast. Again, we started with the field house, and I think we had this assembly on 3 sides of the field house, and 2 sides of the ice rink. And the head condition we had throughout, across multiple different systems, including masonry. But the insulated metal panels really went up in a matter of weeks. The wall was done. There were trims and things like that. As you can see, this is an aesthetic trim that was say glazed into that extrusion at the base to finish the detail off, but they went up very quickly. We were very happy about that. That's what we were shooting for because we had to get these up before the snow really started flying in the field house so we could complete the rest of the work.
When you start considering the process.
No, that's wrong. Big difference.
True.
But no, this went up, we started it in the fall. I think we tested it right before Thanksgiving. So it was great. And I think we had one failure in the field house. That was a gasket that was out of place. The panel came off, corrected, put back on, retested, and it was fine. So this, again, Intertech was the third-party company that Colby College had hired to do the independent testing. And it went through the same parameters that we had to do in the performance model. So nothing changed. This is just some examples of where we had tested the curtain wall system. But we did static tests and dynamic tests on multiple systems. And in addition to the performance mock-up, we did what we called an aesthetic mock-up, which is what you see on the upper left. That was taking all the various components, the masonry, the curtain wall, insulated metal panel, translucent panel, and slot system, and incorporating them just to make sure that everything came together. We knew performance-wise and functionally it was going to work, but we still have to marry up some of these details architecturally. So we did use that. That was a good learning tool, but definitely got much more out of the performance mock-up earlier on. Very glad we did it. So overcoming challenges of design assist. Again, it's not perfect. The more you do, the better you get at it. But first and foremost, the question we get is, well, how are we going to obtain competitive pricing? How are we going to keep people honest if there's only one person, one company that's at the table? They can just name their price. Well, we overcome that by competitively bidding the design assist effort with subcontractors. After that competitive bid, we chose to enter the subcontractors into a guaranteed price, maximum price contract. So they were then obligated to competitively bid all the work they weren't going to do themselves. All their subcontractors, all the material suppliers. So we got to see their competitive bids to make sure that we were still getting a competitive edge. So that took away 90% of the competitive pricing concerns. Added upfront costs in the process. Yeah, there's added upfront costs. Design assist is not free. You're bringing more people to the table earlier on. That's going to have an added cost. However, you're going to be reducing, well, the alternative is you play the whole process out, which, as I mentioned before, would take quite a lot of time and spend a lot of money. So it's a bit of a leap of faith going, trust us. If we spend this money now, you will save it. You will have saved it at the end. Greater time for design, very similar. Yeah, design is going to take much longer with that component. However, again, looking at them as individual components, if we were to try, Sasaki were to try to design this without the input from subcontractors, market specialists, it would go back and forth, change orders. The design process would continue through construction. There would likely be delays in construction due to material procurement. So although there's greater time in design, that's only looking at it with a narrow vision. Overall, without question, it saved at least 6 months on the total project.
We wouldn't
Time
have time.
translates into money.
Yeah, we wouldn't have time for the performance mock-up, which was a key feature in this. Without that, this is all invented stuff. No one's done this before, and so without proving it out, and that's the only way we're going to do it in a lab, we wouldn't have the time. I would also say the biggest way to overcome challenge is the attitude of collaboration. Everybody has to come to the table with the understanding of the greater goal and the willing to compromise to achieve that greater goal. And you know, you're not going to get far if you bring in the my way or the highway attitude. So we had a good team there that was up for the challenge. They were very engaged in what we're trying to do, and I think it shows in the end.
Design liability, I think, is another key point. It's a risk that can be overcome by explaining in more detail in writing upfront what the expected roles, responsibilities, and liabilities are going to be with each of the participants. That keeps everybody honest. There's very little ambiguity when you do it that way. And again, the more of these you do, the more detailed some of those roles and responsibilities get, just like with any other scope of work. This didn't go well in my last project. I got to make sure I capture that risk this way, or I tell this person to do that. You'll add more in, it'll get that much tighter, that much better. One of our biggest challenges in that market being more central Maine was unfamiliarity with this process. Consigli is familiar with it. Consigli has done it, but that market, with the project consisting of about 60% local contractors, they were not. So again, it was incumbent upon us to explain that process, explain the risks to everybody, to make sure that we were being completely transparent, because that's what we wanted to get out of this process: complete transparency and collaboration. And that wasn't going to happen if anybody was hiding something, or someone didn't understand, the contractor didn't understand. If they think they're going to lose money, they're either going to jack their number way high, or they're going to bow out, and we won't get that good competitive edge. So taking the time to explain the process to the client, to the subcontractors, to your market is an absolute must. And we chose to do that in a couple of different ways, not just with the RFP process. We also brought subcontractors in just for a sit down to explain what it is the project was all about, what we wanted to do, what we wanted to get out of it. And the response that we got from it was absolutely tremendous. People were excited about it. It was something different than they had traditionally seen in the market. And they recognized that with a GMP, while they may not have as much opportunity for profit, their risks for losing that, their profit went way down. So it was a very good compromise. They saw the benefit of it, and post-construction, most of the people that participated in it said, "This is great. We'd love to do this again." Design assists, subcontractor GMP, they loved it. So we would highly recommend it. And I would hold up this design assist effort, specifically with the envelope, as one of the absolute successes of the project. It was an excellent experience, not without troubles and hurdles that we have to overcome, but it was a great experience. I could not have imagined trying to do this in one of the more traditional methods. There were a lot of people there. There were a lot of interests being covered, but it was a great experience.
Great.
That's it.
Well, thank you so much.
Talk to us about the like time commitment to like design meetings. Like, what do you guys budget for meeting with these contractors? Like once a week, couple hours?
I think we met weekly. Yeah. At least during the start. There was obviously a lot of work that had to go into understanding the intent that Sasaki and Hopkins wanted to achieve, and then how to go back and figure out how to make that work with standard assemblies, and then later custom assemblies, make it all work. So, but not every week.
Yeah, I think it started rationing up when we developed the extrusion, because once we had that piece, the design team needed to go back and sort of understand what we had. So we had to test it out, in the building, And then when we were comfortable with, how we wanted to treat it, that's when we really went full bore. And when Chris says weekly, it's like weekly all day in Milford. With everybody at the table. And so, and we just go like, instance to instance to instance from the base all the way to, and vice versa.
It was that, how do you eat an elephant one bite at a time? We'd look at a detail. First, it was the extrusion, that assembly, we had to make that work. And then once that worked, how can we apply that to the various scenarios? And then we just went scenario by scenario, working out everything that went into it, around it, just one by one. Go ahead.
You mentioned that, Colby really stepped up and paid for those extrusions kind of early on in the design assist process. You already had your sort of team build with total wall on board and whatnot, but who actually sort of like, purchased those dies and, ran those extrusions? Did Sigley kind of run that, or was Total Wall already leading that?
That was, again, that was communicated as part of the requirements for Total Wall in that transition from pre-construction to construction. So that was contracted to them to purchase enough of it to make sure that we could have it for our mock-up, for initial inspections. And then after that, we could order more. Once we knew that concept-wise it was going to work, then they were released under their GMP contract to release the rest of the project.
Understood. So that the acknowledged risk there on behalf of, Total Wall and also the others, that may end up with the bad.
Yeah, the die is $5,000. The real risk is, well, how much of this extrusion are we gonna run? And
Did you
before
have
knowing if
issues
it's gonna
running
work.
minimums or anything like that, or that wasn't the real?
It was, the die was built with the understanding that the commitment with Kingspan that we were going to be running the whole lot. So there was still some risk there that we were gonna have to meet those minimums. So it was a lot of finger crossing going, we need to make sure this is gonna work. But by the time even that first die lot and set of extrusions were produced, everyone was 90% confident, having gone through it at that point, that it was gonna work. And it was just that the performance portion that we needed to tweak.
Yeah, the material extrusion, we felt confident that it could handle the dead load, the lateral load that was embedded. It was just, how do you marry the panels to it, make it airtight, weathertight?
And I have one question related to the extrusion from Greta. She said, how did the team address a thermal bridge at the framing of the captured panel systems?
So there's a big fat black block in there between, I don't know if you can go to like the photo of the extrusion, somebody holding it up.
This one?
Yeah. That's the thermal break in there. So it's continuous right through the system, and it's screwed into the
There's also on the back side of the extrusion, between the extrusion and the outrigger, there were pads that gave a thermal break between the steel and the extrusion. So we tried to build in as many different breaks as we could. If you go forward, there might be a shot of it on the actual steel. Keep going, keep going. Keep going. The ones in the.
Oh, the other mock-up?
Yeah,
Oh.
back up. So you can see some of these are the outrigger plates. On the back of those plates, we had a thermal break there as well.
Oh, okay.
You ran the physical testing, and assuming you also did theoretical testing and learned speed of that.
Yeah, we had Arrow.
Was in charge of doing those testing, total wall or?
Air did the initial testing to make sure that, we're on top, but Thermal Wall had an obligation also.
Total Wall did thermal testing and analysis on their assembly. But then as you get to the base, and you get to the head, there are other contractors at play there. So Total Wall was fine. We'll thermally test our system. And I think they even opted to test the upper and lower as well, but they said we didn't design those components. We designed assisted with it, but they own the delegated design for the extrusions and everything in the middle. So Era also, I think, participated in some of those thermal models after the design assist process, no details were. Right.
What was the presence of the designer on the construction site during construction?
It was about once every 2 weeks to start, and then as construction ramped up, they were on site every week.
Like once a week or twice a week?
What, 2 days a week? 2 days a week. Yeah, I should do one trip a week.
Yeah.
It's a more fair way to put it. So obviously they, Massachusetts, Hopkins would come over, I don't know, once a quarter, maybe.
Yeah.
Then COVID hit, and we never saw him again.
Until afterwards.
Until after it was finished. But, no. Once construction ramped up, it was essential to have a design team presence on site.
And that was
It was 2 days a week.
It was mutually agreed upon, because I think initially we were thinking that we would go every other week, 1 day every other week. And as things intensified, I mean, there was just a lot of decisions that yet to be made, that it kind of needed design presence to be on the spot and to help guide. So we did agree that that it was 2 days a week, weekly, until the end. And that was me.
Was that very like set when you would go? So like, or was it
We
kind
had,
of?
we had a routine. And Chris gave me a nice office in the trip.
You were there like a full day rather than like maybe 2 hours or 3 hours.
Come in like the night before, get started, first thing in the morning, and then leave at the end of the day.
At what point or milestone did you decide to stop the design assist process?
When you had to deliver to the GMP.
Yeah. Once we knew everything was going to work, and some of it was forecast. Because we technically had our GMP before design assist had finished, but we had predefined how long design assist was going to take. So we had our own little mini schedule of, well, we have to hit this date because. So we had laid out what the level of participation was going to be. They built that into their pre-con price. And then they provided estimates for us to build into our GMP. They said, just based on how design assist was going, yep, this is going to work. And then that rolled into their construction contract with their guaranteed maximum price contract. So there was a lot of projecting of costs and then committing to schedule milestones. We didn't have to actually actualize any of that or all of it before we committed. We were able to project it and then hold the line on the costs and the schedule.
We weren't completely finished with design assist, but we were obliged to get all the details into the contract documents too. So that was also another issue that we had to, make sure that the scope was covered in our drawings.
The performance mock-up ended up being, well, we decided prior to our GMP going into it, the performance mock-up would be built into their GMP contract, not their pre-con design assist contract. All of the meetings and the collaboration, the modeling, the engineering, the preliminary engineering that went into the manufacturers, that was part of design assist. The performance mock-up, the ordering of the initial run of extrusions, and then obviously everything that followed, that went into their construction.
It almost had to be that way because you had to do the delegated design engineering in order to build that performance mock-up. So it seemed like that made sense.
And the mock-up had its own separate submittal assembly. So it was a mini version of what we were going to do on the building, but some of the details were unique enough where we did our own shop, did a separate submittal package for shop drawings, engineering calcs, extrusion, and everything that went into it, and then repeated that again for the entire building. Once we got further through the performance.
It's like the performance mock-up and all submittal involved with that kind of happened after design assist was over.
It wasn't over, it was half, 3/4 of the way.
Okay.
Because then we had to take what we learned from the mock-ups. And in some instances, we had to go back to the table. They weren't catastrophic, but like, well, there's enough where at least half of the group here needs to get together and talk about what happened, why it happened, how do we fix it? And then once everyone came to that conclusion, how to fix it, we'd go back out, we'd do another, we'd fix it and make another test. Either find some other problems or finally found them all and fixed
You sort of just answered this question, you said you did shop drawings for the mock-up, but shop drawings didn't come after the design assist process, they're gonna be subject to project specific engineering and all this, but as part of your design assist contract, did you specify, because it kind of looks like it did, that certain typical details would have to be resolved to a shop drawing level in the design assist process, or did that only happen through the necessity of producing the proposal?
We
Is this it? Yeah.
Consigley had worked with Sasaki, Hopkins, and Eric to a point, develop the details, which is what Jerry had said before. Beyond that, we said, we can't completely define in detail what this thing is, where everything comes together without bringing on more specialty trades, engineering and all that. And then as part of our process, we defined what the expectations were going to be. We need this thing, this assembly, that assembly, we need those detailed enough where you could then go into shop drawings for the building. And at that point, your GMP would take over. So the overall requirement and the cost for that requirement and the time, the schedule for that requirement was dictated as part of the design assist contract. And then equally, their GMP picked it up from there and said, all right, everything before this is design assist, everything after this is GMP.
One question related to design assist phasing. I think it would be good to discuss the concept versus early design assessment. Nowadays, we see some of the soft consultants with Arrow. And nowadays we see that design assessment is being pushed to 100% SP, which for us as a consultant that in design is a little bit too early because we don't get to do enough coordination with the mechanical, with the sustainability, with the structure. So there is a level of risk in going into design assessment a little bit early, so maybe you can talk a bit about that.
I wouldn't do it at SD. It's like you said, it's too early.
Yeah.
The
We
design
don't
team,
know enough about it.
yeah, everyone's still trying to figure out what the intent is and the massing of that. And once you can get that fine tuned enough to narrow the parameters of what you want the design assist effort to be, then you can bring people in. And we found that DD is an appropriate time. Beyond anything before that, we're introducing people too early and their opinions too early, and it will stifle the design team and actually go against what it is that we're trying to do.
I'm not even sure we even knew this was insulated metal panel back in schematic design. I think we're still thinking they were all brick boxes.
$150 million project, and we were still struggling with budget and all that, like any project would. So we had to overcome that before we could start working on the details.
I have two online questions. One is, was there any additional interior insulation? And the second was, do you think we'll see a higher percentage of design assist projects going forward?
No interior insulation, everything was handled by the envelope and even at the edge, like, when we could stuff mineral wool, that's what we added. I'm seeing design assist much more now. It's like every project I'm working on, there's going to be some component of design assist. Where I would say like 10 years ago, it's like it would be a big deal to bring somebody early on board.
We're seeing it more, we're encouraging it more. But again, it's got to be that right set of circumstances, that it's got to be right for the project. We don't want it to be a buzzword and just say one size fits all. If it meets all the parameters, then yeah, we've been encouraging it as a time saver, as a money saver, long-term. Like I said, I would highly recommend it if it meets those parameters.
Any other questions?
Yeah, but-
Maybe just a statement. I would imagine for the warranty too. I know owners are big on warranties and people have the individual manufacturer's warranty, but pulling everything under one contractor is attractive. I imagine. Yeah, I didn't hear it mentioned. So, but, yeah.
Well, that. Yeah, one contractor, if we had tried to have multiple contractors within that one contractor housing another contractor, draining into the other contractor's system. And then down onto the curtain wall from another contractor, we would have had 3 to 4 separate subcontracts. If and when there was a problem, it'd be this all day. Having one gone through the design assist process and being confident and owning everything that, all right, everyone bought into this, and whether, even though the design team put the stamp on it, everyone essentially put their stamp of approval on it. So it would be very, very difficult for anyone to come back and say, I don't own that, or I'm not gonna do it. There were situations where Total Wall had to come back out, and we would have some pretty big storms, and they had a couple leaks really in one spot that kept reoccurring. We replaced the panels and did all the details again, and it kept coming back until we found that there was water coming over one of the gaskets. That was solved by some AVB addressed it. But yeah, for a warranty situation, I couldn't imagine having 4 contractors in that system.
Having done a very similar design assist myself, knowing what you know now about the weak spots with the IMP, would you do this again?
Huh. Well, yeah. Let's dig into that a little more. Would you do what again? Design assist, or would you do the?
No, design assist, I'm a huge fan, and that used to be my full job when I was my last employer, but the IMP I find
I think if you
sounds
had
awesome, but until you start, it's a simple system and it's meant to be kept simple, and as soon as you try to make it do things that it doesn't want to do, sometimes it gets tricky.
the thing I always worry about IMPs, and it's like, and frankly, I think this is my only IMP project I've worked on. It's because it's a barrier system, and so I wish that there were a redundancy to it. And you can build some kind of redundancy in it. But if I would only do it if it had the rigor of the team behind it, because everybody was invested in it. It's like Consigli was a good watchdog to make sure, it's like any air leak, any water coming through, you flag it, you take care of it. And if you don't have that rigor, especially out in the field, because I think that's where most of the failures occur. It's like the workmanship. If you're not on top of it, it could be an issue.
The insulated metal panel solved a very specific problem. I don't think it's anything that either party is going out and going, we have got a facade for you. Cover your building with the brand new Jerry extrusion. It solved some of our problems. It solved all of our problems that we had mentioned here. For that, it served its purpose. But in a perfect world, we would have put up masonry. just like we had put up everywhere else, but time didn't allow, budget didn't allow, and this just came in just under that threshold.
I am proud of this thought, you know, I love the scale of it. I love the look of it. It sort of, it hit that modernist aesthetic that was part of Hopkins. And so I'm not gonna sort of judge IMPs, but I am very proud of the process that got me to this solution.
We've gone through a similar process for other projects, it's always the fact that we have to rely on, you know, site installation workmanship is always the issue. So if you have someone to be on top of.
Yeah, Colby College hired Intertech, again, as a third party. They didn't just do testing. They also were their envelope consultant. So they came out periodically to do inspections, making sure that Consigli and our subcontractors were adhering to the details that everyone had built and followed through on. And like anything, sure, they found deficiencies that needed to be corrected, which they were, and we moved forward. So it was a good process. Even the follow through after the fact, even in the more traditional method, went very well. I attribute that to this process and what we went through.
All right, any other questions? So another.
All right, thank you everybody for attending. Like I said, this is the first in a three-part series on design assist. During our next month presentation, March 1st on Wednesday, there's going to be a great team from Payette coming in talking about the design side and what the designer and sub-consultants look like for design assist. So everybody please come back for that one, that'd be great. And please sign in if you haven't, even if you don't need the continuing education credit. You never know when you may need a certificate of completion. So please sign in before you leave. Have a good one, everyone.
Thank you.
Thank you.
It's really warm. It's great.
Another consecutive.
Yeah, I know.
What a pleasure. This was before Darby. This was 28, yeah. This was before Darby. Yeah, presentation honestly, but they wanted to, there was discussion about bringing Cornwall and I was like, we got third party during the. For criteria. We did that. Yeah, you know, they're like my favorite, you know, Steve Levack's like, well, well. You know, let me check for it.
Who did this? Was it you?
Okay, so we had 25 people on the line, 25 people in the room, so that's a lot. We should have, like, off road.
As well for the next one too.
Yeah, right.
Feel free to head out, do what you need to do.
Yeah.
Yeah.
Are you gonna be in office?
Okay, I have a site visit that's tentative.
Wow, yeah. Flash, yeah.
You were able to measure?
Yeah.
One of us went to using
Yeah.